Hi. That's amazing. They all like to say hi. So on the count of 3. 1, 2, 3. Hi. Okay. Now it's all business here today. We're learning to graph quadratic equations. Quadratic equations. We spent a whole unit graphing linear equations. Talked a little bit about other equations. Do you guys remember what we said every quadratic equation is when it's graphed? Mark?
A line with a curve.
Yes, and it's a very particular named curve. Michael? A parabola. Very good.
Wait, I thought that was a hyperbola.
No, the hyperbola was when we had like xy equals 3.
Isn't that the same thing like that?
No, the hyperbola had the branches, the 2 branches like this.
Really?
And this. Yep. So we didn't do a lot of these. Because we waited to this point, because once you have the skills that we now have, it becomes easier to graph these. This is a picture of a parabola here. Yeah,
On the exam, we have to know how to graph it.
Yeah, we graph hyperbolas by making XY charts, and yeah, that's probably something you need to know. Okay, so this is a parabola. This picture here is a picture of a parabola, and in our objectives, we say we're going to graph quadratic equations by finding the x-intercepts, if any, the vertex and the axis of symmetry. So I just wanted to point out what we're talking about in the big picture here today. This is a parabola, so it's the graph of a quadratic equation. The x-intercepts are where, what do you think the x-intercepts are? We talked about them in just linear equations. We know y-intercept is what? What's the y-intercept on a graph, Mary? Like if I'm graphing an equation and I, like y equals mx plus b, the y-intercept is where, what happens on the graph?
Where the line crosses the y.
Where the line crosses the y-axis. Good. So the x-intercepts are what? The x-intercepts then are where what, Robbie?
Crosses the axis.
Right. So these would be the x-intercepts right there. And the vertex is the point, like the top, the very top or the very bottom of it. So that's the vertex. These are the x-intercepts. You guys know what symmetry is. An axis of symmetry kind of cuts it into 2 mirror images. So this is the axis of symmetry. Those are the things we're going to learn to find over the course of the next 2 days to help us graph quadratic equations. Okay? So the x-intercept, there's 2 of them in this particular parabola. This side and this right there. Okay? So those are the 3 things that we'll be talking a lot about. Okay, so we have here an equation, y equals x squared minus 2x minus 3. The graph of this equation is, right away you should look at it and you say, oh, this is going to be not a line, but a what, Mark?
Parabola.
Parabola.
It's a box one where you've got to click the box.
I know.
Did you have to type it?
Yes. Honestly. That was weird. It's never happened to me before. All right. So the first thing that we want to do to graph the parabola is to find the x-intercepts. Well, on the x-axis, what do we know for sure? What is the same everywhere on the x-axis? What thing is always the same? Michael? Yeah, y equals 0 all along the x-axis. So to find the x-intercepts, we capitalize on that. We use the fact that y equals 0 all along the x-axis. Yes, Mark?
Why is it on the x? I don't understand.
This is the x-axis. This is the y-axis. We're looking for the x-intercepts. Points on the graph where it crosses the x-axis. What do we know about y there? Y is 0. So to find the x-intercepts, we can use the fact that y equals 0 there, right? Currently, we have 3 ways to solve for x in a quadratic equation. Robbie? You can factor it. You can, Michael? Use the quadratic formula. What's the other one? Spent a couple days on it. Andrew?
Isolate X.
Isolate the
X squared.
squared term, yep. And sometimes we had to manipulate it in that. What did we call that whole process?
I don't.
Completing.
Oh, square.
Completing the square. Is that what you were gonna say, Mark?
Yeah.
Good. Completing the square. Which one of these 3 methods doesn't always work? Doesn't always work.
Factor.
Factoring, right? Some of them you look at and they're not factorable. Good. Which strategy do you think is easiest? Well, that all depends on you individually. Which one do you like the most, Mark? Quadratic formula.
Although I'm horrible at it.
You'll get better. Anyone else prefer something else? Michael?
Yeah.
You like completing the square? I like factoring if it's factorable, but it doesn't always work. So that's kind of just letting you know that I care about what you think is the easiest.
Wait, can we set up a proportion?
No. All right. So we are going to set y equal to 0 in order to find the x-intercepts. All right, and we're going to solve for it. So if the quadratic equation I'm looking at is y equals x squared minus 2x minus 3, and I want to know the x-intercepts, I'll get the x-intercepts at the point where y is 0. So I put in a 0 for y. And then it looks just like the equations you've been dealing with to solve, to get the root score. Today, to practice, we want you to use the quadratic formula, even if that's not your favorite method. All right?
Thank God.
So, Andrew, here's your test. Without taking an actual homework test, what's the quadratic formula?
Wait, so x equals negative b plus or minus the square root of b squared minus 4ac over 2a.
Very good, Andrew.
Oh, good.
All right. So,
Memorize that fact.
remember our a, b, and c are the coefficients in this quadratic equation. So, what is the opposite of b, Kelly?
Square.
Good, positive 2.
Thank you.
Plus or minus
Good practice.
b squared is going to be what, Saf?
Wait.
4. Negative 2 squared is 4. Minus 4. A is 1. C is negative 3. My experience shows me the kids make the most mistakes by being reckless with their signs. All over what, Annika? 2A, good. Which means 2 times 1. Okay? So I got a lot of simplifying to do here. We got 2 plus or minus. 4 times 1 is 4, times negative 3 is negative 12. So this is 4 minus negative 12, which is 4 plus 12. Do you all agree with the square root of 16?
Oh, shoot.
There, you agree? All over 2. This can simplify to 2 plus or minus 4 over 2. Which means I get 2 plus 4 is 6 over 2 is one of my answers. And 2 minus 4 is negative 2 over 2 as my other one.
Oh, this is cool, actually.
So this is the same as positive 3, and this is the same as negative 1. Now those are your x values when y equals what, Robbie? 0. So my ordered pairs for my x-intercepts are, what's 1, Mark? Oh,
Negative 1?
negative 1, comma, What's the value of y?
Zero.
0.
And then the other one would be 3, 0.
3, 0. Those are my x-intercepts, the 2 points where the parabola crosses the x-axis. All right? So we got that so far. Any questions so far? Good. All right. Now we got to find the vertex, that top or bottom point. Okay? Because the parabolas are symmetric, like I showed you at the beginning, we drew that dashed line down the middle. We know that the vertex is exactly halfway between the 2 x-intercepts. Michael?
So, does that intercept be 2?
All right, so let's refresh our memory. What our 2 points we just wrote down were 3, 0 and -1, 0, right? So we want to find what's halfway between 3 and -1. Michael? 1. And if you're not sure how Michael got that, there's a couple steps, right? We got to find the distance between 3 and -1 and divide it by 2.
Oh, can we graph that?
No. Just 4 divided by 2, which is 2. So 2 units is the halfway point. So Michael, you backtrack 2 units from 3, or you go up 2 units from -1, and you get that your x value for the vertex is +1. Okay, because it's 2 units in the middle of these 2 numbers. Okay, all right. Yes, Mark?
And actually just plug in the 1 for the next equation.
Yes. So now we know the value of x at the vertex, but we don't know its corresponding y. So to get its corresponding y, we plug in what we know x, and we solve for y. So right now we know the vertex is +1 something. We got to find that y value.
I mean, was it just a coincidence that it becomes -2 -3?
Yeah. So I'm plugging in my 1. I got to square it. -2 times 1 -3. So my y value must be 1 -2 -3, and that is a coincidence mark.
That's so cool.
-1 to -4. So the vertex is at 1, -4. We now have our 2 x-intercepts and our vertex.
That's awesome.
Okay? Any questions? All right. So, the axis of symmetry is a vertical line going through the vertex of the parabola. It cuts the graph in half. Remember what you know about vertical lines? They're in the form of x equals some number. So what's the equation of the axis of symmetry for this parabola?
Oh.
We know that, this is just a quick sketch here, here's our axes. We know that our vertex is at -1, 4, that's what it was, right?
1 -4.
1,
The opposite.
yeah, 1 -4, thank you.
You're welcome.
1, and this is -4. Where's the axis of symmetry going to be?
Oh,
You guys should call him Mark.
yeah.
Okay, Mark?
Thank you. It would be like directly up from where the point is. Like,
Yep.
Straight up.
It's this whole line. So what's the equation of this line?
It's. Oh, I actually know this.
Yes.
It would be x -5.
You're making it more complicated. What do we know all along there? Kelly wants to get in the game.
Wait, no, I was just gonna say, but
Oh,
technically,
it's vertical
it
line.
does it cut the graph in half?
Oh, this is so easy.
What do you mean, Kelly?
Because like it's not. It's not on
Oh,
zero.
yeah, we don't have our vertex points on here. When you look at where the vertex points are on this, it does cut it in half. Yeah, we don't have that. That's okay. Robbie?
Oh,
X equals 1. It's the same as the value of the x value of the vertex, because it's a vertical line there. Okay.
I'm never gonna hear the end of that from Robbie.
Okay. That's okay.
No, I was saying x -5 equals y.
Okay, before we put it all together, I want you to look at this really quick. These parabolas can either open up or they can open down. you can predict right away when you look at your quadratic equation which one it'll do. So I've got 4 quadratics graphed here for you. 2 of them open up, and 2 of them open down. Can you tell what could help you figure out if it's going to open up or down? Kelly, can I call on you this time?
Sure.
Okay.
The quadratic term, I believe it is negative when it opens down.
Yeah, very good. The coefficient on the quadratic term is negative when it opens down. You see this? Negative there. And you see this negative here. When it's positive, it opens up. Okay, so that can help you predict it. So, positive coefficient on the quadratic term, the parabola opens up. And the negative quad term, it opens down. Okay, so that's just a good little like double check, self check type thing when you're going through here. All right, so let's put everything together. We learned that the x-intercepts were, what were they in? 1,
1, -4.
or no,
No, they were,
negative,
no, -2 and 3. -2 and 3. No, it's -2 and 3.
It was negative 1 and 3.
negative 1 comma 0 and 3 comma 0, right? And what was the vertex? The vertex mark was
1 -4.
1 and -4. And our axis of symmetry was what, Seth? X equals 1. So we put it all together. We graph our x-intercepts. Negative 1, 0. 3 comma 0, 1, 2, 3. Our vertex is 1, -4. 1, 2, 3, 4. Our axis of symmetry is that line through there. So our parabola, and we can double check, our vertex is down here, our points are up here, should be opening up, and that makes sense because our coefficient was positive. And then we just kind of sketch it in. No perfect science here.
Yeah, they should have like parabola. That'd be awesome.
Okay, there is our parabola. Questions?
Do we need to draw the line of symmetry?
Yep,
About it? Or
Yep.
solid?
got it.
Is that like standard?
Yep.
Okay.
Okay, that's a lot of pieces to put together, right?
Yeah, I feel like it's easier than the other, I don't know.
Wait, this is a little,
Yes, sir.
we already had our last test, right?
Yeah. Supposed to, we're looking at a quiz on Wednesday. If we, it'll be a quick quiz, it won't be extensive. All right. Okay, let's work on another one. Let's work on one more. Let's not quite try it on our own yet.
Okay.
All right. All right, so here we have a quadratic equation. We need to find the x-intercepts, the vertex, and the axis of symmetry. Just looking at the quadratic equation, are you predicting it opening up or opening down? Opening up or down? Hanukkah?
Opening it up.
Opens up because?
Because positive.
Yep, this term right here has got a positive coefficient, so we should predict one opening up. All right, how do we get our x-intercepts? Let's start with our x-intercepts. What do we know on the x-axis? What do we know on the x-axis? About y? What do we know about y on the x-axis? Bobby?
0.
It's 0. So we take and we set our equation equal to 0. And then we got to solve it. We have all of those methods, but today we asked you to use the quadratic equation, right? So go ahead and use the quadratic equation. I'll talk through it up here while you do it. X is going to equal, what's the opposite of b, Mark?
8.
8. Plus or minus square root of b squared. Suneri? 64. Minus 4. A is 1. C is 12. All over what, Annika? 2a, which is 2 times 1, which is 2. All right. Now it's just simplifying. 64 minus 48. Robbie, is that 16? Yes. Okay, so we got x equals 8 plus or minus 4 over 2. Oh. 8 plus 4 is 12 divided by 2. One of my values of x is 6. And 8 minus 4 is 4 over 2 is 2. My other is 2. You guys agree with 6 and 2? What's my y coordinates, Maha?
0.
0, right? The y value on the x-axis is 0. All right, what about the vertex? How do we get the x coordinate of the vertex? Remember, the idea of symmetry helps us here. What do we do to get that? It's the key idea. You remember? Monica? Yeah, it's halfway between those two x-intercepts. So I got 1, 2, 3, 4, 5, 6, 0, and 2, 0. You can do 6 minus 2 is 4 divided by 2, so it's 2 units from either one. So what's my x value of my vertex going to be? It's 2 values, 2 units between there. Saf? 4. So my x is 4, but how do I get my y? How do I get the y? Andrew, do you know how you get the y?
You put in 4 for x in the equation.
Good. You put in 4 for x and solve for y. So go back to your original equation. Y is going to equal 4 squared minus 8 times 4 plus 12. So this is 16 minus 32 plus 12. I get 16 plus 12, I get negative 4. You guys agree? So I got 4, negative 4. Okay. What's my equation for my axis of symmetry? Mark?
X equals 4.
Good. X equals 4. Now we get to sketch it in. Once you've done all that, that's smart. And you're done.
This is not
No, there's a lot of steps, but you'll get a lot better at it. So for your homework tonight, I'm going to give you a worksheet. There's 2 problems on the front, 2 on the back. I just want you to do the front. I want you to try to do the 2 on the front, and then I want you to go back and redo 2 quadratic formula problems that you got wrong from the last assignment.
So for homework then.
That's right. Questions?
Nope.
Say bye.
Say bye.
Bye.
Bye. So,